Section 5 of The Mentor 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Matthew Datcher. The Mentor 1 by Various. The Weather, Serial 110, July 1, 1916, by C.F. Tallman, of the United States Weather Bureau. Old Probabilities. Shall tomorrow's weather be fair or foul? Blow wind, blow moistly from the south, for I go a-fishing. Nay, good friend, exclaims the golfer, the day must be dry, and the wind in the west. The farmer moistens his finger and points it toward the sky. Rain, come quickly, for my crops, is his prayer. But the maiden's voice is full of pleading. Let the sun shine tomorrow, that my heart may be alight on my wedding day. And so through the days and seasons, humanity, with all its varied needs, turns anxiously, entreatingly to old probabilities. And how is it possible for him to satisfy the conflicting demand? He may on the same day please the farmer in the west, the fisherman in the south, the golfer in the northern hills, and the bride in the eastern town. But how can he suit them all in one locality on a single day? Old Probabilities is willing, and he loves humanity, but his powers and privileges are limited. There are those who say that it is due to the kind endeavors of Old Probabilities to satisfy everybody that our weather has at times become so strangely mixed. Old Probabilities is a gentle family name and came out of the affection of the people. The name was a matter of pleasantry. It was given to the chief of the United States Weather Bureau when the department was first established by Congress, and its source lay in the phrase, "It is probable," with which all weather predictions began. But Old Probabilities, genial prophet and lover of his fellow men, is passing away. For the officer who organized the Weather Bureau became in time displeased with the name and changed the form of the daily prediction so as to read, "The indications are." The phrase is formal and severe. There is naught but cold comfort in it. Our hearts turn back fondly to Old Probabilities and his friendly assurance, "It is probable that tomorrow will be fair." The Weather by Charles Fitzhugh Tallman, Librarian of the U.S. Weather Bureau. It is easy to lay too much stress upon the unimportant aspects of weather. It furnishes a bit of conversation over the teacups. It accentuates the twinges of rheumatism. It spoils a holiday. All this, however, is mere byplay. The real work of the weather, the work that explains the existence of costly weather bureaus, such as the one upon which our government spends more than $1.5 million annually, is momentous beyond calculation. Consider such facts and figures as these. The head of the British Meteorological Office recently declared that bad weather costs the farmers of the British Isles about $100 million a year. In our own country, it has been estimated that a difference of 1 inch in the rainfall occurring during July in 6 states means a difference of $250 million in the value of the corn, maize crop. The world over, the damage wrought by hailstorms is said to average about $200 million a year. In the city of Galveston, a single hurricane once destroyed $20 million worth of property and 6,000 human lives. Thus we might proceed indefinitely. The fact is that man's welfare is conditioned to an enormous extent, and in an endless variety of ways, by the vicissitudes of the atmosphere. Hence the study of weather, meteorology, is one of the most important of sciences. It is also one of the most strikingly neglected. At the office of the Weather Bureau in Washington, there is a meteorological library of some 35,000 volumes. But meteorological libraries are rare. Meteorological books are scarce in other libraries, and meteorologists are so uncommon that whoever declares himself one is likely to be asked, "What is a meteorologist?" The meteors studied by the meteorologists are not shooting stars, but the phenomenon of the atmosphere, rain and snow, cloud and fog, wind and sunshine, and whatever else enters into the composition of weather and climate. The atmosphere. The ocean of air in which human beings live, even as deep-sea fishes live at the bottom of the liquid ocean, is called the atmosphere. Unlike the liquid ocean, it diminishes rapidly in density from the bottom upward. At an altitude of 3½ miles, it is only half as dense as at sea level. This is higher than the highest permanent habitations of man. Mountain climbers and balloonists have attained greater altitudes, but above a level of about 5 miles, the air is too greatly rarefied to support life. Balloonists who ascend still higher must carry a supply of oxygen with them. A little above the 10-mile level, the air is only 1/8 as dense as at sea level. The atmosphere extends at least 300 miles above the earth, at which height its density is computed to be only 1/2,000,000th as great as at sea level. The weather with which human beings are concerned may be said to extend upwards 7 or 8 miles, i.e., to the level of the higher clouds. The layer of the atmosphere lying between sea level and the upper cloud level has certain characteristics that distinguish it from the air above it, and is known as the troposphere. The heating of the atmosphere by the sun is the beginning of all weather, and the temperature of the air is the most important weather element. As soon as we begin to study atmospheric temperature, we encounter a paradox. The heat of the air is all derived from the sun, except a minute quantity from the interior of the earth and an infinitesimal quantity from other heavenly bodies, and it would therefore seem at first glance that the upper layers of the atmosphere should be warmer than the lower. Experience proves the reverse to be the case. A mountain overgrown with tropical vegetation on its lower slopes is, if high enough, crowned with eternal snows. A thermometer carried upward in the air shows under average conditions a fall of temperature of 1 degree Fahrenheit for every 300 feet of ascent. This fall of temperature with ascent continues to the upper limit of the troposphere, where the average temperature is something like 70 degrees below zero. Above the troposphere is a region called the stratosphere, or isothermal layer, in which an ascending thermometer shows irregular and generally small changes of temperature, not infrequently a rise of temperature with ascent. The exploration of the stratosphere is one of the most fascinating fields of meteorological research, but lies somewhat beyond the scope of an essay on weather. It is carried out chiefly with the aid of small free balloons, some of which, sounding balloons, bear self-registering thermometers and other instruments, while others, pilot balloons, bear no instruments, but show by their movements the drift of the air currents. The greatest altitude ever attained by a sounding balloon was 21.8 miles, by a pilot balloon, 24.2 miles. The branch of meteorology dealing with the study of the upper air is called aerology. Reverting to the temperature of man's environment, the reason why the atmosphere is warmest at the bottom is this. The sun's rays come to us from outer space in the form of vibrations in the ether, and warm the air only to a slight extent in passing through it. They are absorbed by the ground and converted into heat waves. The air is then warmed by contact with the warm ground. Lastly, the warming of the lower air gives rise to air currents, which distribute the heat through the atmosphere. Barometric pressure. If our weather were uniform, it would furnish little matter for conversation. In fact, would hardly be weather at all. Changeableness is a salient feature of weather, and to understand weather changes, one must know something about barometric pressure. Like all other forms of matter, the invisible air has weight. At sea level, it exerts a downward pressure averaging 14.7 pounds to the square inch. Atmospheric pressure is measured by means of an instrument called the barometer, in which the weight of the air is balanced against a column of mercury. As the height of the mercurial column varies with the pressure of the air and is taken as a measure of the latter, we follow the practice of expressing pressure of force in linear units, inches or millimeters. This practice is retained even in the use of the aneroid barometer, which contains no mercurial column. Hence, when we say that the average barometric pressure at sea level is 29.92 inches, we are really expressing in a roundabout way the weight of the air at that level. Barometric pressure not only varies somewhat regularly with altitude, diminishing as we ascend, but also less regularly from place to place in a horizontal direction and from time to time at a given place. In studying the weather, meteorologists frequently wish to compare the barometric pressures prevailing at a certain time at a number of places lying in the same horizontal plane. Given a system of meteorological stations scattered over a certain territory, the first step is to secure simultaneous readings of the barometers at these stations. Then, if the stations are at various altitudes, as they commonly are, corrections must be applied to the readings to reduce all to a common plane. The plane adopted for this purpose is sea level. Since most stations are above sea level, and since atmospheric pressure diminishes with altitude, reduction to sea level generally involves applying an additive correction. The weather map. Now please attend carefully to what follows, because I'm going to attempt to put into a minimum number of words the essential facts concerning the weather map, the best clue to weather mysteries yet devised by man. At about 200 stations of the Weather Bureau distributed over the United States, the barometer and other meteorological instruments are read twice a day at 8 a.m. and 8 p.m. Eastern Standard Time. The readings are promptly telegraphed in cipher to Washington, where they are entered on a map. The barometer readings at different stations reduced to sea level, just as explained, will vary, say from 29 to 31 inches. Lines called isobars are now drawn through places having the same pressure, the intervals between the lines corresponding to differences in pressure of 1/10 of an inch. Lines, isotherms, are also drawn to connect places having the same temperature. A little arrow at each station shows the direction of the wind at that point, and various other symbols are used to facilitate the interpretation of the map. But the isobars are more important than anything else. Here is the weather map for the morning of July 9, 1886. The solid curved lines are isobars, representing barometric pressures ranging all the way from 28.7 to 30.8 inches. It will be seen at a glance that these lines tend to assume roughly circular forms, enclosing regions where the pressure is lower or higher than the average. Moreover, the little arrows which fly with the wind show that the winds round a center of low pressure tend to blow in a direction contrary to that followed by the hands of a clock. In the southern hemisphere, the reverse is true. But instead of blowing in circles that are inclined somewhat inward toward the center, round a center of high pressure in the northern hemisphere, the typical circulation of the winds is exactly opposite, clockwise and inclined outward, though the accompanying map does not show this particularly well. An area of low pressure with its system of winds is called a cyclone or low. An area of high pressure with its system of winds is called an anticyclone or high. Note that a cyclone is not necessarily a storm, though the one shown on this map with its center not far from New York City was a very violent storm, which, when this map was drawn, was sweeping up the Atlantic coast. Popular usage applies the term cyclone to the tornado. The strength of the winds in a cyclone depend upon the contrast in barometric pressure between its center and its outer border. A cyclone with crowded isobars always has strong winds. When the isobars are widely spaced, the winds are gentle. These areas of low and high pressure, in addition to their movements about their centers, move bodily across the country in a general west to east direction at an average speed of over 500 miles a day. This double movement may be compared to that of a carriage wheel rotating and advancing at the same time. Most of our cyclones enter the country from the Canadian Northwest, though many come from other regions, and nearly all of them pass off to sea in the neighborhood of the Gulf of St. Lawrence. Their route across the country varies greatly, depending in part upon the season. The weather in cyclones and anticyclones. Barometric pressure is not an element of weather in the ordinary sense of the term, since the fluctuations of pressure that occur in the human environment are entirely inappreciable to the senses. We have seen, however, that pressure is intimately related to wind, which is a weather element of much importance. In noting that systems of high and low pressure are constantly traveling across the country, and that they are accompanied by winds having fairly definite characteristics in relation to each, we have taken an important step toward bringing order out of to the uninitiated, chaotic sequence of weather. Obviously, a system of telegraphic weather reports makes it possible to keep close watch of these wind systems, and from their locations on today's weather map to form some idea of where they will be tomorrow. Thus, the weather forecaster is enabled to give notice of the imminence of those violent winds that destroy life and property at sea, and to a less extent on land. There is an element of uncertainty in such predictions, since storms, unlike railway trains, are not confined to fixed routes and regular schedules, but the practiced forecaster acquires an instinct that helps him to forestall their vagaries. Now, what is true of wind is also true to a certain extent of the other elements of weather. They bear typical relations to the distribution of atmospheric pressure. Cyclones are usually preceded by rising temperature and accompanied by cloudiness and rain or snow. Anticyclones are usually preceded by falling temperature and attended by fair weather. Referring again to the map of January 9, 1886, and following the course of the isotherms or temperature lines, we see that abnormally cold weather prevailed over the middle western and southern states. The isotherm of 0 dips far south across northern Texas, Arkansas, Mississippi, Alabama, and Tennessee, while in the upper Mississippi and Missouri valleys the temperatures were from 20 to 40 degrees below zero. These regions were, in fact, in the grip of a severe cold wave which had entered the country a day or two before, preceding the anticyclone here seen central north of Dakota. Cold northwesterly winds were sweeping over the Great Plains and as far south as the Gulf. The same map shows typical weather accompanying the cyclone central on the Atlantic coast. From the seaboard west to the Mississippi Valley, rain or snow had fallen within the previous 24 hours, indicated by shading, and snow, indicated by S, was falling at the moment of observation at a majority of stations within this area. Elsewhere in the same region, the weather was cloudy. The foregoing remarks indicate, in a general way, the significance of the weather map and the principles upon which scientific weather predictions are based. The endless procession of highs and lows brings to any place on the map constant alternations of heat and cold, storm and sunshine. The forecaster watches the procession and draws his inferences as to what will happen in this or that part of the country within the next day or two. 48 hours is about the limit of his outlook. Long-range forecasting is still a thing of the remote future. Forecasts for a week in advance are indeed made by the Weather Bureau with the aid of reports from a chain of stations extending around the globe, but these are in very general terms. In January 1914, the Bureau began publishing a daily weather map of the Northern Hemisphere. This publication is, at present, suspended on account of the war. Some weather miscellanies. It would require a book rather than a brief essay to describe all the vicissitudes of weather, and many books that attempt to do this have been written. We have space here only to mention a few important features of the weather met with in our country. The southern and southeastern part of a cyclone, some hundreds of miles from the center, is a favorite breeding ground for thunderstorms and tornadoes. Thunderstorms of the type known as heat thunderstorms also occur with no special relation to cyclonic centers in regions where the ground has been intensely heated. In either case, the storm is built up by rapidly ascending air, which cools and condenses as water vapor, first into enormous clouds, cumulonimbus or thunderheads, and then into rain, frequently accompanied by hail. It would be necessary to go to some length to explain the familiar electrical manifestations of thunderstorms. Some points indeed are not perfectly clear to meteorologists, but it should be stated that these are always the result, not the cause of the storm. Lightning is an electrical discharge between cloud and earth, or cloud and cloud, and thunder is simply the violent sound wave set up by the sudden expansion of the heated air along the path of the discharge, the same acoustic phenomenon that accompanies an ordinary explosion. A tornado, popularly miscalled a cyclone, is an extremely violent vortex in the air, usually less than 1,000 feet in diameter. Besides its very rapid rotary motion, it has a progressive motion at a speed averaging 40 or 50 miles an hour. Its position at any moment is marked by a black funnel-shaped cloud, which grows downward from the sky and does not at all times reach the earth. A waterspout at sea is an identical phenomenon, though usually less violent. Along its narrow path, the tornado demolishes everything. Wooden houses are blown to splinters, trees uprooted or stripped of their branches, structures of heavy masonry laid in ruins. Something like 100 lives are lost each year in these storms, on an average, and one of them, St. Louis, May 27, 1896, destroyed $13 million worth of property. A blizzard is a high, cold wind accompanied by blinding snow, which in winter sometimes blows out of the front of an advancing anticyclone, especially in our north-central states. A similar wind, with or without snow, is called in Texas a norther. A chinook is a warm, dry wind that descends the eastern slope of the Rocky Mountains in Montana, Wyoming, and Colorado, and flows northeastward over the plains. Its effects are most pronounced in winter when it brings about a very sudden rise in the temperature, in extreme cases as much as 40 degrees in 15 minutes. It causes snow to vanish as if by magic and is appropriately nicknamed the Snow Eater. Cloudburst is merely a picturesque name for a very heavy shower, usually a thunder shower. West India hurricanes occasionally visit the United States, especially in the late summer and early autumn. These storms begin as violent cyclones of small extent, 300 to 600 miles in diameter, usually somewhere east of the West Indies, swept in a long curve across the Caribbean Sea and then turn north, either passing up along the Atlantic coast or crossing the Gulf of Mexico into the southern United States. Soon after entering the temperate zone, they increase in size and diminish in violence, but are still vigorous enough on reaching the Gulf or South Atlantic coast to cause great devastation. Low-lying shores are often inundated by the immense waves they generate. Frosts in the spring and autumn are also predicted with great success to the immense advantage of farmers, market gardeners, and horticulturalists. The practice of smudging or heating orchids, now so widespread, is usually carried on under the advice of the Weather Bureau, which gives prompt notice to the orchidist when such precautions are in order. The Bureau publishes charts showing the average and extreme dates of the last frost in spring and the first frost in autumn for all parts of the country. A fog is a cloud resting on the surface of the earth. In the United States, fog is commonest among the northern and middle parts of the Atlantic and Pacific coasts. In the interior of the country, especially the western part, it is of rare occurrence, the average number of days a year with fog being less than 10. Lastly, weather fallacies are rife. Indian summer is merely a type of mild, hazy, heavenly weather that prevails intermittently during our long American autumns. The equinoctial storm is a myth. The climate has not changed anywhere within the span of a human lifetime. One year differs from another, but there is no progressive or permanent change, and the moon has nothing whatever to do with the weather. The open letter. What is lightning and what causes it? The question came to us a few days after we had made announcement of a weather number of The Mentor. It was a natural question, for lightning is the most sensational of all weather phenomena. It has always had a fearful sort of fascination for humanity. To the ancients, it came as a bolt of wrath from the hand of Jove. To the fire worshippers, it was a warning message. To parched travelers, it was a bright promise, for it heralded the coming of rain. To the superstitious, it was a signal flash from the spirit world. And to those of nervous temperament, it was a highly disturbing phenomenon, producing emotions varying from uneasiness and alarm to hysteria. The question, then, what is lightning and what causes it, has an interest for all. I refer it to Mr. Tallman, the author of the Mentor article on the weather. His reply follows. Not so many generations ago, natural philosophers thought that inflammable gases exhaled from the earth took fire spontaneously in the air, and that this was lightning. The idea also prevailed, and it is not yet quite extinct, that a stroke of lightning involved the hurling down from the sky of a mass of rock called a thunderbolt. In the 18th century, people became quite familiar with the process of generating, by friction, a mysterious something called electricity, which, when it passed from one body to another through a small layer of intervening air, produced sparks. Several philosophers noticed the resemblance between these sparks and lightning. It remained, however, for Benjamin Franklin to prove that lightning was really an electrical discharge on a large scale. The experiments by which he proposed to demonstrate this were successfully performed, first by others in France, and then by Franklin himself at Philadelphia. With the aid of his famous kite, he drew down from a thundercloud a little of the electrical fluid, as it was then called, and produced tiny sparks from an iron key at the lower end of the wet kite string. We do not even yet know what electricity is, but we know a great deal about the way it behaves and the effects it produces. There are two kinds of electricity, which we call positive and negative. A body is said to be charged when it has an excess of either kind, and the two kinds have a tendency to unite and neutralize each other's effects. Thunderclouds become heavily charged with electricity. We are not quite sure how this happens, but it is now commonly believed that the strong uprising currents of air that occur in the storm in the process of breaking up the water drops in the cloud also separate positive from negative electricity, leaving the former in excess in the part of the cloud next to the earth and carrying the latter far aloft. By a process called induction, the positive charge in the cloud draws an excess of negative electricity to the surface of the ground underneath. The stronger the contrast between these opposite charges, the harder they try to break through the interposing barrier of the air, which is a poor conductor of electricity, and to neutralize each other. At length they succeed in doing so. A powerful stream of electricity flows for an instant between cloud and earth. Its passage heats the air and makes it luminous, just as the passage of an electric current heats the filament of an electric lamp and makes it luminous. This is lightning. These discharges occur not only between the clouds and the earth, but also, and probably more often, between clouds charged with opposite kinds of electricity. The sudden expansion of the heated air along the path of the discharge affects our ears just as does the sudden expansion of the air at the mouth of a gun when it is fired. In each case, a wave is sent through the air in all directions from the place of disturbance, and our eardrums are set in vibration. That is thunder. Take courage then, you timid ones, who wince in the lightning's flash and tremble under the thunder's roll. Thunder is simply a vibration of your eardrums, and when you hear the thunder, be assured all danger is over. W. D. Moffett, Editor. Weather Services at Home and Abroad. Monograph number 1 in the Mentor Reading Course. Posted up in public offices, in hotel corridors, and other conspicuous places in our cities, the official weather map is a familiar sight. Even more familiar is the official weather forecast, displayed as a roll on the first page of the daily newspaper and sent broadcast over the country on the little brown cards which one may see in the village post office as well as in the city drugstore. When a great storm sweeps over land or sea, detailed official reports concerning its progress and characteristics are published in the daily press. When a lawsuit involves a dispute as to the temperature or the state of the sky on a certain day, the official weather records are consulted. How much do you know about the branch of the national government that is charged with the duty of keeping watch of the weather, recording its vagaries as they occur, and also predicting them as far as is humanly possible? Besides its office in Washington, where more than 200 persons are constantly employed, the Weather Bureau has about 200 stations manned by professional meteorologists and observers. One of these will be found in almost every large city, while some are in towns of very modest importance. A regular Weather Bureau station is well worth a visit. The instrumental equipment of these stations is almost superhuman in the accuracy with which it sets down on paper the chronicle of weather happenings from day to day and from moment to moment. Little less marvelous is the system by means of which weather information, past, present, and future, is disseminated from these official foci. The post office, the telephone, the telegraph, wire, and wireless are all pressed into service to the fullest extent, especially in giving timely notice of approaching storms and other destructive forms of weather. These agencies are supplemented by visible and audible signals in the shape of flags, lanterns, railway whistles, and so forth. Contrary to popular belief, the Weather Bureau does not exist primarily for the purpose of telling the public, with a considerable margin of uncertainty, whether it will be advisable on the morrow to carry an umbrella or wear an overcoat. The important work of the Bureau is twofold. It consists first in the prediction of those atmospheric visitations, such as storms, floods, and cold waves, which endanger life and property on a large scale, and second, in the maintenance of the records that form the basis of climatic statistics. In both these directions, the Bureau splendidly justifies its existence. Our National Weather Service was founded in 1870 and for 20 years was maintained by the Signal Corps of the Army. In 1890, it was established on the present basis as the Weather Bureau of the Department of Agriculture. Most civilized countries possess official services for the observation and prediction of weather, though no other is organized on quite so grandiose a scale as ours. The British Meteorological Office, the Prussian Meteorological Institute, the Central Meteorological Bureau of France, and the Central Physical Observatory of Petrograd are among the leading institutions of this character in the Old World. Admirable weather services also exist in India, Japan, Australia, Canada, Argentina, and elsewhere. Meteorological Instruments, monograph number 2 in the Mentor Reading course. The history of meteorological instruments dates back at least as far as the 4th century before the Christian era, when the depth of rainfall was measured in India by some form of gauge. We again hear of rain gauges being used in Palestine in the 1st century of the present era. Thermometers with fixed scales were used in Italy in the 17th century, and the great Galileo, born in Pisa in 1564, took part in perfecting these instruments. Wind vanes were known to the ancients, the earliest one of which we have any record surmounted the famous Tower of the Winds at Athens. In the Middle Ages, the weathercock became the usual adornment of church steeples. The barometer was invented by Torricelli in 1643. Most meteorological instruments, however, are of quite recent origin, and this is true especially of these types of apparatus that make automatic records, thus replacing to a large extent the human observer. Our picture on the other side of this sheet shows the instruments used by the cooperative observers of the Weather Bureau. These observers, of whom there are about 4,500 well distributed over the country, serve the government without pay, and their painstaking observations have alone made possible a detailed survey of our climate. In the picture we see, on the right, an ordinary rain gauge, and on the left, a thermometer screen containing 2 thermometers, namely a maximum thermometer for recording the highest temperature of the day, and a minimum thermometer for recording the lowest. The screen, which is of wood painted white, serves to shield the instruments from the rays of the sun while permitting free ventilation. Under these conditions, the thermometers show the temperature of the air, whereas when exposed to direct sunlight, a thermometer shows the temperature acquired by the instrument itself, and this may differ materially from the air temperature. In contrast to this simple equipment, we find at a regular meteorological station or observatory an impressive collection of apparatus for observing and recording nearly all the elements of weather. The pressure of the air is measured by the mercurial barometer and registered continuously by the barograph. The temperature of the air is automatically recorded by the thermograph. Other self-registering instruments maintain continuous records of the force and direction of the wind, the amount and duration of rainfall, the duration of sunshine, the humidity of the air, etc. There are also instruments for measuring evaporation, the height and movement of the clouds, the intensity of solar radiation, the elements of atmospheric electricity, and various other phenomena of the atmosphere. Clouds and Rainfall, monograph number 3 in the Mentor Reading course. The International Cloud Classification, now generally used by meteorologists, is an amplification of one introduced by an ingenious English Quaker, Luke Howard, in the year 1803. Howard distinguished 7 types of cloud, to which he gave the Latin names cirrus, cumulus, stratus, cirrocumulus, cirrostratus, cumulostratus, and nimbus. In passing, it may be of interest to note that a few years after Howard's classification was published, an attempt was made by one Thomas Forster to introduce popular equivalents of these terms. Forster proposed to call cirrus curl cloud, cumulus stacken cloud, stratus fall cloud, etc. In other words, he assumed that because Howard's names were Latin in form, they were unsuitable for use by the layman, and therefore needed to be supplemented by English names, although the proposed substitutes were, on the whole, somewhat longer and more difficult to pronounce than the originals. A parallel undertaking would be an attempt to discourage the public from calling the windflower anemone or virgin's bower clematis. Forster's superfluous names have never taken root in our language. The highest clouds, cirrus and cirrostratus, are feathery in appearance and consist of minute crystals of ice. Their altitude above sea level averages about 5 miles, but is frequently much greater than this. All other clouds are composed of little drops of water, not hollow vesicles of water as was once supposed. Neither crystals nor drops actually float in the air. They are constantly falling with respect to the air around them, though as the air itself often has an upward movement, the cloud particles are not always falling with reference to the earth. In any case, their rate of fall depends on their size. In the case of smaller particles is very slow. Under some conditions, the particles evaporate before reaching the earth, while under others, they maintain a solid or liquid form and constitute rain or snow. A fog is a cloud lying at the earth's surface. Rainfall is one of the most important elements of climate, chiefly because of its effects upon vegetation. It is measured in terms of the depth of water that would lie on the ground if none of it ran off, soaked in, or evaporated, and this is, in practice, determined by collecting the rain as it falls in a suitable receiver or rain gauge. Usually the gauge is so shaped as to magnify the actual depth of rainfall in order to facilitate measurement. Snow is measured in 2 ways. First, as snow, and second, in terms of its water equivalent. The latter measurement is commonly effected by melting snow and pouring it into the rain gauge, where it is measured as rain. By this expedient, we are enabled to combine measurements of rain and snow in order to get the total precipitation of a place during a given period. Nature is notoriously partial in her distribution of this valuable element over the earth. A region having an average annual rainfall of less than 10 inches is normally a desert, though irrigation or dry farming methods may enable its inhabitants to practice agriculture. The heaviest average annual rainfall in the United States, not including Alaska, is about 136 inches in Tillamook County, Oregon. The rainiest meteorological station in the world is Cherrapunji, India, with an average of about 426 inches per annum. This is the latest official record. There are several rain gauges at Cherrapunji, and the average amount of rain collected by any one of them varies considerably with the length of the record. Hence the widely divergent values of the rainfall at this famous station published in encyclopedias and other reference books. The Outposts of Meteorology, monograph number 4 in the Mentor Reading Course. The expression used in our title seems a fitting one to apply to a number of meteorological observatories and stations maintained for the benefit of science in regions remote from the comforts and conveniences of civilization. Some are on the summits of lofty mountains, the ascent of which is laborious and even perilous. Others are situated in the bleak wilderness of the circumpolar zones. Public attention has all too rarely been called to the heroism and self-sacrifice of the men who constitute the staffs of these lonely outposts. The institution shown in our gravure, officially known in honor of the Dowager Queen of Italy as the Regina Margherita Observatory, crowns the summit of Monte Rosa on the northern Italian frontier and is 14,960 feet above sea level. It is devoted not only to meteorological investigations, but to studies of the physiological effects of great altitudes and various other researches, and is open to the savants of all nationalities who are courageous enough to scale the second highest summit of the Alps. It is habitable for only about 2 months, namely, from the middle of July to the middle of September. Each year, a temporary telephone line is constructed connecting the observatory with the plains of Italy. It is the highest telephone line in the world, and its installation is an arduous undertaking. A permanent line is impossible on account of the shifting of the glaciers and snowfields on which the poles must be erected. There is also a meteorological observatory on Mont Blanc, but it is not at the summit and is not quite so high as that on Monte Rosa. The solar observatory, which once stood at the very top of Mont Blanc, no longer exists. The United States Signal Service, now the Weather Bureau, formerly maintained observatories on Pikes Peak, 14,134 feet, and Mount Washington, 6,280 feet. The loftiest of meteorological stations was, however, that formerly operated by Harvard College Observatory on the summit of El Misti, Peru, 19,200 feet. For a number of years, the United States Weather Bureau maintained a large and important observatory at Mount Weather, at the crest of the Blue Ridge near Bluemont, Virginia. In the Old World, one of the most famous of mountain meteorological observatories was that which stood on Ben Nevis, 4,406, the highest summit in the British Isles. This was closed in 1904. If the conditions of life at these high-level stations are such as to repel any but the ardent lover of science, the same is true in even greater measure of those endured by the little band of meteorologists who manned the observatory maintained by the government of Argentina at Laurie Island in the South Orkneys, on the verge of the Antarctic. Every year, a party of 4 is sent out from Buenos Aires to spend a year of exile in this inhospitable spot, which is generally icebound and has not even wireless communication with the rest of the world. This station has been in operation since 1904. The staff, which is changed each year, has embraced men of several nationalities, Scotch, American, and others. Far within the Arctic Circle, 2 meteorological observatories are maintained in Spitsbergen, but these are at least connected with the world by radiotelegraphy. If the hopes of Explorer Parry are accomplished, an observatory will, one of these days, be established at the South Pole. The Air Above Us, monograph number 5 in the Mentor Reading Course. Meteorologists are not content to limit their investigations to the stratum of air lying close to the Earth's surface. Even before the demands of aeronaut for information concerning the structure and phenomenon of the atmosphere far overhead became pressing, many efforts had been made to secure such information in view of its important bearing upon many scientific problems. As long ago as the year 1784, a balloonist, equipped with various meteorological instruments, made an ascent from London and brought back an interesting series of observations which were communicated to the Royal Society. For more than a century, the manned balloon was the principal means of sounding the upper atmosphere. Nowadays, as a rule, the meteorologist, instead of going aloft in person, sends up a kite or a balloon to which are attached automatically registering instruments. When the aerial vehicle returns to Earth, its record shows in detail the conditions encountered during the journey. Everybody remembers how Franklin brought lightning from the clouds, but it is a far cry from the simple apparatus that served Franklin's purpose to the box kite of modern meteorology. Science has perfected the kite almost beyond recognition. It has been shorn of that crucial feature of the schoolboy article, the tail. Even the kite string has become several miles of steel piano wire wound around the drum of a power-driven winch, with elaborate apparatus for recording the force of the pull and the angles of azimuth and altitude. Captive balloons are sometimes used for similar investigations. When, however, it is desired to attain great altitudes, the meteorologist has recourse to the so-called sounding balloon, which is not tethered to Earth. This is usually made of India rubber, and when launched is inflated to less than its full capacity. As it rises to regions of diminished air pressure, it gradually expands and finally bursts at an elevation approximately determined in advance. A linen cap, serving as a parachute, or sometimes an auxiliary balloon which does not burst, serves to waft the apparatus with its delicate self-registering instruments gently to the ground. This commonly happens many miles, sometimes 200 or more, from the place of ascent. Attached to the apparatus is a ticket offering the finder a reward for its return and giving instructions as to packing and shipping. Sooner or later, it usually comes back, though often months after it falls. Indeed, the large percentage of records recovered, even in sparsely settled countries, is not the least remarkable feature of this novel method of research. The instruments attached to the sounding balloons register the temperature of the air, the barometric pressure, and sometimes the humidity. By means of the sounding balloon, the air is explored to heights of 20 miles and more. The records obtained by means of these balloons have within the past 15 years completely revolutionized our ideas concerning the upper atmosphere. Still another device employed by meteorologists is the pilot balloon. This is also a free balloon, but carries no meteorological instruments. Its motion in the air is followed by means of a theodolite, and it serves to show the speed and direction of the wind at different levels. During the winter of 1912-13, a pilot balloon sent up from Godhaven, Greenland, by a Danish exploring expedition reached the unprecedented altitude of more than 24 miles. Our Winters, monograph number 6 in the Mentor Reading Course. In the year 1781, Thomas Jefferson wrote in his Notes on Virginia, "A change of climate is taking place very sensibly. Snows are less frequent and less deep. They do not often lie below the mountains more than 1, 2, or 3 days, and very rarely a week. The snows are remembered to have been formerly frequent, deep, and of long continuance. The elderly inform me that the earth used to be covered with snow about 3 months in every year." Probably long before the white man came to America, the patriarchs of the Indian tribes regaled the young men and maidens gathered about the campfire with reminiscences of the deep snows that prevailed in a previous generation. In short, the old-fashioned winter is a perennial myth perpetuated by a familiar process of self-delusion. The occasional periods of abundant snow make a more lasting impression upon our minds and the long intervals in which this element was scarce or lacking. The resulting misconception is promptly dissipated when we consult the weather records, which in some parts of the country extend back more than a century, and prove that there has been no actual change in the climate within the period they embrace. Of course, the erroneous idea is, in some cases, due to the fact that one's childhood was spent in a part of the country in which the snowfall is normally heavier than in that where one has recently lived. The average yearly snowfall over the New England states, New York, and the borders of the Great Lakes is from 50 to 100 inches and upward. Over the north central states, it is much less. In the southern tier of states and along most of the whole of our Pacific coast, snow is a rarity. The heaviest snowfall in this country probably occurs in the high Sierra Nevada of California, near the border of Nevada. In some places in these mountains, more than 40 feet of snow falls in an average winter, while more than 65 feet has been recorded in extreme cases. Here it is a common occurrence for one-story houses to be buried to the eaves or above. The Southern Pacific Railway, which intersects this region, has built 32 miles of snowsheds at a cost of $42,000 a mile over single track and $65,000 a mile over double track. In an average year, $150,000 is spent on these sheds in upkeep and renewals. Flat-roofed houses are unknown in this vicinity. All roofs are gabled at a sharp angle to shed the snow. A picturesque feature of our American winters is the ice storm, so enthusiastically described by Mark Twain. When a leafless tree is clothed with ice from the bottom to the top, ice that is as bright and clear as crystal, when every bough and twig is strung with ice beads, frozen dewdrops, and the whole tree sparkles cold and white, like the Shah of Persia's diamond plume. Such is the artist's view of the phenomenon, but alas, these same ice storms cause endless inconvenience and heavy expense every winter to the electrical industries by breaking wires.